Hi. Today's quest is to find the set difference between two sets. But the sets are given as um, any type of arrays, and the difference has to be symmetric. So it's not just all the elements from one argument that's not in the other argument. It's only those elements that appear in exactly one of the arguments, but not in both of them. Let's get started. We have here a character vector, and here's another character vector, and we can see that both of them have an A, and both of them have an L, so those characters should not appear, and what we should get instead then is a D, a Y, and O, and G, and P from this one over here. And let's make an anonymous lambda, a defen. Here we refer to our left argument as alpha and our right argument as omega. And we want to consider all the elements and then remove the ones we don't want. And all the elements we can get by using the union of these two. So a set union, we're treating these character vectors as sets. And the ones that we want to remove are the ones that are in both. So that's the intersection between them. And then we can use the set difference between the union and the intersection. And for symmetry, we can put parentheses here, though that's not strictly necessary. Right? This, however, is a really great example of what is called a dyadic fork. Notice that if we think of the functions involved in the algorithm, we have here the union function applied to the arguments, and we have the intersection function applied to the arguments, and then the results of those two function applications become the arguments for the set difference or without function. And for that, we can use the fork construct, which does exactly that. Fork construct is just three consecutive functions in isolation, and it reads nicely, the union without the intersection, and that's exactly what it does. So this is a neat way to write it. Another approach that we could use is to say that we have all the elements from one argument except those that appear in the other argument. And similarly, all the elements in the other argument that are not in the first argument. And then all we need to do is to merge the two. And that could be using a union or just concatenation. And there's no really any reason to write a union because we know that they must be all different. So we can just concatenate them together. Here we have something that looks like the fork construct with the same function on the right and the left. And the trick is that we have the arguments swapped. Otherwise, it would have been exactly the same on the right and the left. So how can we do this? In order for us to apply the fork construct, then we need to have the left argument on the left and the right argument on the right. We can modify, using a monadic operator, the set difference function, which is not symmetric, to swap its arguments. So this tilde diaresis, it derives a new function, which is the same as the old one, except its arguments are swapped. So now we can put the alpha on the left and the omega on the right. And with that, we can clean up to get just the functions in isolation and use the nice fork syntax. But there is a catch, and that is that we're not guaranteed that our arguments are vectors or scalars. They might have higher rank. And for such a thing, let's say we put in the comma bar function, which is then applied to this argument over here, and it gives us a column vector. Let's try that for a moment. So if we try to do that, then we get an error. And the same thing would be if we use our other function over here. Same kind of problem, a rank error. So what we want to do is before we start applying the main part of the function, we need to pre-process both arguments to make sure that they are just vectors. And we can do that because we have a special operator, the addic operator. So it takes two functions, combines them, and the comma, when used with just one argument, which is what this operator will do, it is a flattening operation or revel. It destroys the outer shape, but it keeps all the elements intact. So if you do that, it will work, and the same thing goes for our other function over here. This will also work. So these two are the two solutions. We can give them names. And then we could apply them inline as before. Like that. Thank you for watching.